Good afternoon. Today is the 7th of November. Going to give you an update on where I am with some of this Arduino stuff. Right here you got a scene that I'll be showing a couple of things. I'm going to show you a couple of pictures first, just kind of orient you to what I'm doing with this thing. And so what you can see on my hand here is in the picture. I have the Arduino, which is a SparkFun board, the red one. On top of that is a Bluetooth Adafruit board, shield, and on top of that is a prototyping wing nut board so that I can lock down the cables so they don't come loose. Over here is a 9-volt battery that's actually powering, replacing the normal USB power to the Arduino. And then on my actual hand, I have a 3-degree of freedom sensor, one that I was using for a while ago. Again, it's not the solution that I want, but I just wanted to get some different things working and demonstrate those. I have 2 buttons, LEDs showing the buttons are on, and then there's another button that's linked to this left-hand button. So both these buttons activate the same digital port or pin on the Arduino, and that one's attached to my index finger, and that's what I'll be representing doing a closed fist with. Again, I have different plans for how to actually measure the articulation of the fingers at a later point, but just getting this stuff working. I'll walk through what I have working and then walk through some of the challenges I have ahead of me in order to finalize this. So if I bring this, I'll show you a couple more pictures here. So this is the board. Again, you can see it a little more clearly here. The strap's there just to attach it to my hand. Another perspective on there. Kind of the layout there. Some more pictures just to be able to document how this was set up. And you can see this additional shield here is really not necessary, but it's a really nice thing to have because what I'm able to do is take those wires and plug them in and then screw them down so they don't come out. One of the issues I'm running into right now is that the wires that came with just the practice board are a little short. I already have some solid core coming in of multiple colors, so I should be able to fix that on Monday. Yeah, so there you go. So let's pull this up and go ahead. Let's go ahead and start this. Okay, and so Unity is loading up right now. And so you can see if I tilt my hand. Oh, hold on. One of these is loose. Alright. Let's restart it. So let's go ahead and start this over just because that's acting a little wonky right now because the voltage reference cable is loose and so giving me some messed up values. So again, I have the longer cable, should run into that issue. But yeah, so here we go. So you can see when I tilt my hand, this is tilting. And again, what I mentioned before with this was that as long as the angles I'm looking for are related to a downward position, I'm fine. But you notice if I rotate my hand toward me this way, it doesn't see the articulation around the y-axis because it's neutral or parallel to gravity. So with this, I'll show you. So now I turn my hand, and then the other thing I was working on, kind of update here, was this ability to have a representative hand model in there. And so I ran into some challenges using hinges inside Unity. They kept being really springy, and so it wasn't the look I was going for. And then I tried to use some other stuff in there, the configurable hinge, but I couldn't get that working. So what I did was I set up a whole nest of different game objects, and I've actually replicated hinges myself, and then using local rotations with quaternions, then I actually get the same thing. But it actually does what I wanted it to without all this crazy bounce. So to orient you to what you see, the X, the Y, and then again the Z doesn't work all that great. And then the purple above is showing the orientation of the Arduino. Okay, and then and I have that mimic to the hand model. And then what I do is when I press the button on the side here, you can see when I close my hand. When I press the button on the side, what it does is it articulates each joint by a certain value. And so what that is a placeholder for when I get the potentiometer working in there, and I can actually give it specific values about the articulation or how far my finger's bent. So right now it just goes between two values, and I just have it kind of do a slurp or alert in order to get there. But yeah, it's smooth motion and doesn't look too bad right now. So that's where I'm at with that. Some things I have to add and worked on is one, the potentiometer configuration. Using the actual potentiometer to measure the angle is fairly straightforward for how I'm going to do it anyway. And that's going to consist of, I'll stick a potentiometer on right above the knuckle up by some space X, and then I'll have a branch coming out of the potentiometer, which is a dial, and the potentiometer is like a dial. I'll have a branch coming out of that onto another spacer, which is of size X, so that when my finger is straight, potentiometer will be straight and they'll both be raised up, and then the potentiometer will be out over the knuckle, so that when I bend my finger, the branch bends with my finger, and I can measure like with reference to how the resistance change, the ohm change, how far I am, because I'll do a configuration in order to say, okay, this level of resistance means my finger's straight, and then this new level of resistance means it's bent at a 90 degree, and then I'll just have the function create a range in between. If it's not a linear growth and ungrowth, whatever the word for that is right now, then I'll just have to take multiple points and then just come as close as I can by approximation. So the idea, as you can see with the glove is, or with the model, is that for right now, the proven concept is to show the grip, which is your pinky, ring, and middle finger. That's one. Your index finger is a separate, and your thumb is a third. And I believe if I can represent those three things separately, then I can get a pretty good understanding of what your hand's doing, because it's very rare that we use what I define as the grip fingers independently. So yeah, so that's what I'll go with potentiometers on all three of those in order to get some articulation value there. And then hopefully I can get a 9 degree of freedom sensor in there, so that when I do turn left and right, I can see that turn in the actual simulation as well. And then lastly, I'm still running into the serial port data issues, but I think I've found some different blogs that people wrote about how to address that I think should be successful. I've found 2 or 3 different things that I think once I put them into application, or execution rather, that they should work pretty well. So that's where I'm at right now. I have a decent working model right now that shows rotation of hand, and you can close and make a fist, and if you keep messing with it, you could add different forces to the fist and scripts so that you could actually reach out and grab stuff. Yeah, so got that working. Let's get the serial stuff working. Try and get that 90 degree of freedom stuff working, and then the potentiometers added on, and then probably just reduce the form factor to be a little less bulky and a little bit more stable, and then I should be good with what I try to achieve this semester. If you have any questions or suggestions, advice, or anything like that, just let me know. You can post below or send me an email. Have a good one.